Hello, geometry students. Welcome back to our series on constructions. There are a whole bunch of construction videos out there right now, and there are links to them all in the comments of this. So if this is your first time tuning in, maybe pause, go do some of those other ones. But today, we're going to learn how to create a perpendicular bisector. Okay, so what's a perpendicular bisector? Well, it's all right there in the name. Perpendicular, meaning it is at a right angle, and bisector, meaning it divides it into exactly two even sections. Okay, so let's get to work. I'm gonna share a screen here. All right, let's construct. So let's start by making ourselves a segment, and let's give that segment some endpoints. All right, so we need a perpendicular bisector, and here's how we do it. We center our compass on the endpoint and we grab that other endpoint in our compass. All right, so we are going to do the arc above and below the line. And now we're going to swing around and we're going to do a circle of the same radius, but starting from the other endpoint. And again, go above and below the line. And where these two circles of equal radius intersect each other, we have 2 points here. And any 2 points create a straight line. So, or define one single line, I guess I should say. So we're going to go and connect those two midpoints or intersections. We're going to use our straight edge to draw that line. And that line right there creates the perpendicular bisector of that segment. I don't know. I'm a geek, but I think that's kind of fun and elegant. Now, I chose to do it by grabbing this endpoint and finding 2 points by doing the one above and the one below. But if you wanted, you could actually do this twice and do the one above, as we just did, and then go and grab a different point on that same segment. It doesn't have to be the end point, and create that arc, and then go, oh, I must have lost my footing there, and create the same one from the other side. Sorry, there we go. And notice that point's on the line too. And if I went and did it again from yet a third point, so let's say I'm going to do it from here, there, and I'm going to keep that point. I keep my pencil in the compass because honestly, I feel like sometimes I'm a dingbat and I just forget which point I chose. And that point's right there on the line too. And what we're doing right now is we're actually proving a theorem about the perpendicular bisector, which is the following. Every point on this perpendicular bisector is equidistant from the end points of the perpendicular bisector. So that means that this equals that if this point is on the perpendicular bisector. And same thing, that means that this, and let's use geometry language, is congruent to that. And then finally, this is congruent to that, and so on and so forth for absolutely every single point on the perpendicular bisector. And so then this theorem goes in both directions. If this is the perpendicular bisector, then every point on this line is equidistant from the endpoints of this segment. If a point is equidistant from the end points of a segment, then that point is on the perpendicular bisector. And you can see how this would go a long way in proofs to giving you sides that are equal and angles that are equal, which will then let you use your triangle theorems of congruence, SSS and SAS, and so on and so forth. So We'll do more on that stuff in another, but this was your lesson on how to construct the perpendicular bisector, and then a little bit of a taste of what knowing that something is the perpendicular bisector tells you. All right, keep practicing, and as always, keep mathing.